Good evening, children.
Good evening, ma'am.
Good evening.
Good evening. Good evening,
Good
children.
evening, ma'am.
Good evening, ma'am.
Yeah, good evening. Please do something or the other. Yeah, children. So in this class, we are continuing with Heron's formula. Yeah. So in this question, the sides of a triangle are P, Q, and R. If P plus Q is equal to 45, Q plus R is equal to 40, and P plus R is equal to 35, then find the area of the triangle. Is the question. All right. You see the answer here. Please look at the screen, children. So we are given P plus Q is 45, Q plus R is 40, P plus R is 35. Add the three equations. Add the three equations. So you get P plus P, 2P, Q plus Q, 2Q, R plus R, 2R. So 2P plus 2Q plus 2R is equal to 45 plus 40, 85 plus 35, 120. So on adding the three equations, we get 2P plus 2Q plus 2R is equal to 120. Take out 2 common. Then bring the 2 for division to the other side. So we have P plus Q plus R is equal to 60. But we know that P plus Q is 45. So in place of P plus Q, use 45. So 45 plus R is equal to 60. So R is equal to 15. Okay, now take up another. Now that you got the value of R, we have to find the values of P and Q now. P and Q. All right, so take up this. Take up this. Q plus R is equal to 40. And R is 15. We found R is 15. R is 15. So that way you can find Q. Again, take up the next one, P plus R. P plus R is equal to 35. R is 15. We found here R is 15. So using this, we can find P. P is equal to 20. P is equal to 20. So now what are P, Q, and R? They are the sides of the triangle. P, Q, and R are the sides of the triangle. So the sides of the triangle are P 20 units, Q 25 units, and R 15 units. Now we have to go ahead to find the area of the triangle. So find the semi-perimeter. Semi-perimeter, P plus Q plus R, because the sides are P, Q, and R. So 20, 25, 15 by 2, 30. Area of the triangle, you know, this is the formula. And then substitute the values. Area of the triangle is 150 square units. Understood, children?
Yes, ma'am.
Yeah. See, you can also do this. There are many ways of finding P, Q, and R. See, after when you have this equation P plus Q plus R is equal to 60, you can even substitute for Q plus R. See, not that you should substitute for P plus Q. You can substitute for Q plus R also. What is Q plus R? 40. So P plus 40 is equal to 60. So P is equal to 20. P is equal to 20. See here, P is equal to 20. Okay, you can also substitute for P plus R, 35. P plus R is equal to 35. Then you can find Q. Am I clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, children. Please write down this one quickly. Please write down the question as well as the solution. Done, children?
Just a minute, ma'am.
Okay.
Completed, ma'am.
Very good.
Completed, ma'am.
Good. All of you done?
1 minute.
Yeah, okay.
Completed, ma'am.
All the children. Okay. The sides of the triangle are x plus 1, 2x minus 1, and its area is x root 10. So the sides of the triangle are given to you, x plus 1, 2x minus 1, and its area is x root 10. Find the value of x. So we know the sides of the triangle. Let's find its semi-perimeter. We know the sides of the triangle and the area is given. So we are going to proceed using Heron's formula, for which we need the semi-perimeter. So semi-perimeter is the sum of the sides by 2. Okay, so these are the sides x plus 1 and 2x minus 1. So add everything and divide by 2. How do you work this? Plus 1 minus 1 gets cancelled. Plus 1 minus 1 gets cancelled. And then 2x plus x, 3x, plus x, 4x. 4x by 2. Okay, you can write that. 4x by 2, which is 2x. 4x by 2, which is 2x. Now, so we found the semi-perimeter is 2x. Now the area of the triangle is given to be x root 10. Area of the triangle is given to be x root 10. How do you find the area of the triangle? Root of s into s minus a into s minus b into s minus c. All right. This is the value of s. This is the value of s, a, b, and c. So root of s into s minus a into s minus b into s minus c is equal to x root 10. The area is given to be x root 10. So now simplify the brackets. What do you get? Root of 2x 2x minus x. You can subtract and write x also. I did not do it. So 2x minus x. Here what do you get? When you open the bracket, minus x minus 1. Here minus x plus 1 is equal to x root 10. So square root of 2x minus x is x. And here x minus 1, on simplifying you get x minus 1. Here this gets cancelled and 1. So on simplifying you get square root of 2x into x minus 1 is equal to x root 10. All right. Okay. So now from 2x's we have 2x's here. So 1x comes out of the square root. 2x. So 1x comes out of the square root. And what remains under the square root? 2 into x minus 1. 2 into x minus 1 remains under the square root. There's an x here and x here. So 2x. So 1x comes out of the square root and write the remaining thing under the square root. So root of 2 into x minus 1 is equal to x root 10. Now x and x on both the sides gets cancelled. X on either sides gets cancelled. So we have root of 2 into x minus 1 is equal to root 10. Squaring on both the sides. See, you can do squaring on both the sides here also. Here itself, squaring on both the sides. At any point you can do it. Okay, so squaring on both the sides, you get rid of the square root symbol. You get rid of the square root symbol. So you have 2 into x minus 1 is equal to 10. 2x minus 2 is equal to 10. Or you can take this 2 for division also. You can write x minus 1 is equal to 10 by 2. X minus 1 is equal to 5. X is equal to 6. So the value of x is 6. Since the area is given, children, the area is given. Okay, and the sides are given. So we have to proceed using Heron's formula, for which we have to find S. So that's what we found here. Find S, and then area of the triangle is given to be x root 10. Now use the formula is equal to x root 10. And then it's just simplification. You will have to square on both the sides to get rid of the square root symbol, which you can do at any step. You can do it here also, squaring on both the sides. The root will get cancelled, but you'll have to square this. X square it will become, when you square it on both the sides, the square root is eliminated. Here it will become x square, and this root 10 will go away. It will be x square into 10. When you square on both the sides, this x will become x square. Root 10 will become 10. Take down, children. Done, children?
2 minutes,
Yes,
ma'am.
ma'am.
Okay. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. Yeah. So the sides of the triangle are given to you. Find the altitude on the smallest side. I think this is easy. We'll not do this. So find the area using Heron's formula, and you should find the altitude on the smallest side. So which is the smallest side? 11 centimeters. So you should take 11 as the base and find the corresponding altitude. You can take a screenshot if you want. You must find the area of the triangle. Okay, fine. You can work this yourself. Please do it now. Find the area of the triangle using Heron's formula. And then half base into height is equal to 330. Take the smallest side as the base, 11, and find the corresponding altitude. What, children? Now, supposing the question is, children, if the question is find the smallest altitude of the triangle, what will you do? Find the smallest altitude of the triangle. Okay, keep working and think as to how to answer this question. Please work this one. Yeah, hope you finished working. So here the question is find the altitude of the smallest side. Find the altitude. Actually, it is on the smallest side, not of the. Find the altitude on the smallest side. On the smallest side. So you take the smallest side as the base, 11 centimeters as the base, and you find the corresponding altitude. My question is, how will you find the smallest altitude? How will you find the smallest altitude of the triangle? Any idea? No. All right. So the smallest altitude falls on the longest side. In a triangle, the smallest altitude falls on the longest side. So if you have to find the smallest altitude, you should take the longest side as the base. So half base into height is equal to area, 330. If you want to find the smallest altitude, you have to find h. So which one to take as B? They're asking you to find the smallest altitude. Okay, you have to find h. You have to find h. Then what is B? The longest side. The smallest altitude falls on the longest side. The longest altitude falls on the smallest side. See here. See here. Look at this triangle. So I think I give you a feeling that this is the longest side. I hope you have that feeling that this is the longest side. So see the altitude on it. It's small, but look at this side. I hope I'm giving you the feeling that this is the smallest side of the triangle. But look at the altitude on it. Longest altitude. Are you getting that feeling, children?
Yes, ma'am.
Okay,
Yes.
so yeah. So if you want to find the smallest altitude, which is the shortest altitude of the triangle, take the base as the longest side. See, it's about substituting the correct base to find the relevant height. You want to find the shortest height of the triangle? Take the longest side as the base. If you want to find the longest altitude, the biggest altitude in the triangle, then take the shortest side as the base. So if you take the base as 11 centimeter, that is the smallest side. So this is the height of the longest altitude of the triangle. This is the height of the longest altitude in the triangle. If you take 61 centimeter, if you take the longest side as the base, that will give you the shortest altitude of the triangle. So longest altitude falls on the shortest base, and vice versa. Shortest base. No, not vice versa. And the shortest altitude falls on the longest base. But what's the question here? Find the altitude on the smallest side. Should find the altitude on the smallest side. They're asking you to take the smallest side as the base. Find the altitude on the smallest side. So you should take the side as 11 centimeters and find the corresponding altitude. Tell me, children, if you have to find the longest altitude, which one will you take? Which one will you take as the base?
Smallest side, ma'am. Smallest side.
Yeah, correct. The smallest side. If you want to find the shortest altitude,
Longest side. Longest side.
longest side, you should take 61 centimeters as the base. Very good. Done this one, children?
Yes, ma'am.
All right. Yeah. So how do you find the area of a square given the diagonal? How do you find the area of the square given the diagonal? Half d square. Half d square. Half d square is the formula to find the area of a square given its diagonals. Given its diagonal. You see here, if you want to find the side, this is what you'll have to do. Supposing you want to find the side of the, okay, let me show you the answer. So here I've worked, the area of the square using the formula half d square, because we know the diagonal is 40. And the area of the triangle, isosceles triangle, also using the formula. This is the formula. But you don't use it. You have to use the Heron's formula, children. You have to use the Heron's formula, but you can use half diagonal square to find the area of the square. This is fine. This one you can use to find the area of the square. That's fine. But we normally in CBSE, we don't use this formula to find the area of an isosceles triangle, though you can use it. Meaning, it is a formula which can be used to find the area of an isosceles triangle, but we don't use it in CBSE. I don't know why, but just wanted to share that with you. It's just a formula. That's all it is. I have nothing to say here. Base by 4. Into square root of 4 into equal side square minus base square. Yeah, do this one, children. I'll tell you something else. Please complete this one. See, the area of the kite. What's the area of the kite? The area of the kite is the area of the square plus the area of the isosceles triangle. The area of the kite is the area of the square plus the area of the isosceles triangle. So see here, area of the square plus the area of the isosceles triangle. Square half diagonal square. Diagonal is 40. Diagonal is 40. And the isosceles triangle, this is the formula. And you know the base is 6, equal sides 4. So substitute and find the area of the kite. Do this, children. I'll just come back. Please work this. I'll just come back. Done, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. So half d square or half into diagonal square is the formula to find the area of a square. See, what is the formula to find the area for rhombus, children? What is the formula to find the area for rhombus?
Ma'am, D1 into D2. Half into D1 into D2.
Yeah, half d1 into d2. What's the formula to find the area for parallelogram?
Base into height.
Base to height.
Yeah, so see here. Now every rhombus is a parallelogram. Every rhombus is a parallelogram. The formula to find the area for parallelogram is base into height. So for a rhombus also it will be base into height. Apart from that, rhombus has another formula, half d1 into d2. Area of a parallelogram is base into height. Rhombus is also a parallelogram, so base into height. Apart from that, it has another, its own formula, half d1 into d2. Now, like in a rhombus, in a square also all sides are equal. So a square is a rhombus. A square is a rhombus. See here, now you can see in a rectangle also, instead of base into height, we say L into B. L into B. Now in a square, all sides are equal. In a square, all the sides are equal. The diagonals are also equal. So it is half product of diagonals. Half into D1 into D2 only it is. Like in a rhombus, because a square is also a rhombus. Every square is a rhombus. So the formula to find the area of a square is the formula to find the area for rhombus, half d1, d2. But since d1, d2 both are the same, it is half d1, half d square. Half d square, because there's nothing like d1 and d2. Both the diagonal, in a rhombus, diagonals are unequal. In a rhombus, diagonals are unequal. So we say d1, d2. Half into d1 into d2, because the diagonals of a rhombus are unequal. But in a square, diagonals are equal. So there's something like d1, d2. There's only one d diagonal. So it's like half into d into d. Half into one diagonal d into the other diagonal d. So half d square. Is it relatable, children? Following?
Yes, ma'am.
So what's the formula to find the area for rhombus? Half d1 into d2. In the same way, since every square is a rhombus, the area of a square is half into one diagonal into other diagonal. Half product of diagonals, like in a rhombus. But here it is both d. There's nothing like d1, d2, because the diagonals are equal. So we say half d square. So half d square for a square. So why are we using this formula? We normally use side square, no? That is when we know the side. Area of the square is equal to a square or side square when the side is given. Now here the diagonal is given, so use half d square. All right. So then there's the formula to find the area of an isosceles triangle. So this is easy, right? Base. I've written, that's why I've not used symbols. I've written what the symbols mean. Okay. So like this, we'll have to substitute and find the area of the kite. Understand, children? See, alternatively, you can find the area of this isosceles triangle using Heron's formula. If your teacher also has introduced this formula to you, you can use it. If she's not mentioned this formula to you, don't use it. You can just have it as a part of knowledge. You can find the area of this portion using Heron's formula. Area of the square is half d square. Add both to find the area of the kite. Now, supposing you want to find the side, say you don't know this formula. You don't know this formula. You only know side square. Okay, then what do we do? So you have to find the side, right? So what you do, you connect the other diagonal. You connect the other diagonal, and you know that the diagonals are perpendicular to each other. Okay, and if this is 40, if this diagonal is 40, it's going to be 20 here and 20 here. And we know that the diagonals are equal in a square. So it will be 20 here and 20 here. So now use Pythagoras theorem to find PQ. So what is PQ square? PQ square is equal to 20 square plus 20 square in this right triangle. In this right triangle, PQ square is equal to 20 square plus 20 square. So PQ square is equal to, what is it? 20 square is 400. 400 plus 400. Okay, 800. So root of PQ square is equal to 800. So PQ is equal to square root of 800. So PQ is equal to what is square root of 800? It's a square root of 2 into 400. So 400 means it's 20. So 20 comes out. 400 is 20. So 20 root 2. The side is 20 root 2. Now what's the area? The side is 20 root 2. So what's the area? Side square. So 20 root 2, the whole square. So that is 400 into 2, which is 800. That's what you got here. So if you want to find the side, you should use Pythagoras theorem. Connect the other diagonal perpendicular to each other. Diagonals are perpendicular to each other. You have to find PQ using Pythagoras theorem. This one is 20. This is 20. And this is 20. Because the diagonals are 40 and they bisect each other. So it will be 20 here and 20 here. And you can find PQ using Pythagoras theorem. And once you find PQ, side into side will be the area of the square. Clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah. So please make a note of that. So yes, children. So draw the square alone. Draw the square alone in your book and connect the diagonal. Mark the right angle here. You can call this O and find PQ. Say PQ square is equal to PO square plus OQ square and do it. The alternate method to find the area of the square using the formula side square. Please make a note of that. Again, children, just a minute, I'm coming back. Yeah, done, children? Made a note of that?
Yes, ma'am.
Yes,
All
ma'am.
right. Okay. Yeah, you can do this yourself. Please read the question and answer. Take down the question and the figure, and please work this. Found the area of the triangle, children.
Almost done, ma'am.
Yes, ma'am.
Okay, fine, fine. All right. Okay, let me know once done.
Ma'am, I found the answer.
Yeah, got the area of the triangle?
Ma'am, it's 21 centimeters square.
21 centimeters squared. All right, proceed. I'll see what the answer is. It's on the next slide, but I don't want to show the full answer. So on the base BC, a parallelogram DBCE. On base BC, a parallelogram DBCE of the same area as that of triangle ABC is constructed. Find the height DF of the parallelogram. Try that.
Ma'am, I completed that also, ma'am.
Yeah. What's DF? What's the value of DF?
Ma'am, DF is equal
Ma'am,
to 3 centimeters.
3.
Yes, ma'am.
Okay. Perfect. 21 and 3. Perfect. Yes, children. Or if you can see the answer. I found the semi-perimeter and then the area. The decimal values I converted to fractions, simplified and got the area as 21 centimeters square. And the same is the area of the parallelogram. The area of the triangle and the parallelogram is the same. So area of parallelogram is also 21. Base into height is equal to 21. Base into height is equal to 21. So like that you find the height of the parallelogram. See if my working is correct, children. My subtraction and my working. Please see. Yeah. Done all of you?
Yes, ma'am.
Okay, the others. Need more time, children, or done?
1 minute, ma'am.
All right. Yeah, yeah. Completed, children?
Yes, ma'am.
Yes, ma'am.
Yes,
All
ma'am.
right. All right. Any doubt with the calculation, children? See, after subtracting, we get 10.5, 3.5 here. So I don't want to proceed with the decimal number. So I convert them to fractions. 105 by 10 and 35 by 10, and then cancel. So it'll be 521 times 5 twos are 5 sevens are 5 twos are. Then this 2 and 2 will get cancelled. 4. So you're left with 21, 3, and 7. That's what you see here. Then I write 21 as 3 into 7. Again, another 3 and 7. So 3 into 7, 21. Yes, children, find the area of the trapezium. Find the area of the trapezium. The parallel sides are not given, but it's given it's a trapezium. So which are the parallel sides?
Ma'am, SP and
Excuse me.
ARQ, ma'am.
RQ and SP.
SP.
Okay, correct. SP and RQ. Correct. SP and RQ are the parallel sides. Yes, children, find the area of the trapezium. Yes, what is the area of the trapezium, children? This one shouldn't take a long time. You need help, children?
Yes, ma'am.
All of you?
Yes, ma'am.
All right. So see here. So what is that you don't have here? What's the formula to find the area for trapezium? What is the formula to find the area for trapezium?
A plus B by 2H.
Yeah. Half into sum of the parallel sides into distance between them. Yeah, A plus B by 2 into H, correct. So do you know the lengths of the parallel sides?
Yes, ma'am. They're 7 and 12.
The distance between them is what we don't know, because you cannot take 13 as the distance between them. Distance is always the perpendicular distance between the parallel sides. So this is the perpendicular distance between the parallel sides. So you need to find PQ. You do not know the length of PQ. You need to find PQ. Construction. Okay, so through R, draw, say RT perpendicular to SP. Through R, draw RT perpendicular to SP. So now the whole thing is 12. This one is 7. So how much is this one alone, children?
12, ma'am.
5, ma'am.
5. This side, supposing this T, ST is 5. Because this one is 7. This is 7. So 5 plus 7, 12. So now you can find, RT using Pythagoras theorem. Once you find RT is what is PQ. Or RT itself is the height of the trapezium. We need to find the distance between the parallel sides, which is this one. If I mark this RT here, RT, we need to find the length of the line segment RT. This full thing is 12 and this one is 7. So 12 minus 7, this is 5. This side is 5. Now find, using Pythagoras theorem, find the length of this side. And that is the distance between the parallel sides. Yeah, please do this. Please work, children. Done, children?
2 minutes, ma'am.
Okay. Children, I'm not explaining much because I'm sure it's easy for you to understand, right? Just that the idea did not occur to you. Otherwise, you know this. Yes or no, children?
Yes, ma'am.
Yes, ma'am.
Yeah. Why is PT 7?
Because RQ is 7, ma'am.
Because RQ is 7. RQ is equal to PT. Okay, children. You can even mark a right angle here. Yeah, children. Do this one. Done, children?
Ma'am, can I tell my answer?
Yeah. Yes, Madhumita.
I got 1512.5 centimeters square, ma'am.
No. Area, is it? Area of the rhombus, right?
Yes, ma'am.
No. Yes, others. Class, use the emoji. Raise your hand. Madhumita, Netra, Danya, Raja, Tanishka, Arjun, and Sri Jana. Raja, exams in your school tomorrow?
Not tomorrow.
Then?
It's 8. Ma'am?
Yeah, no. Sometime next week or something then?
No, ma'am. It's
Okay.
on 8th of December.
Okay. So this is the answer, children. Are you all trying it? Getting the answer or you need help?
Ma'am, I got
Working,
the
ma'am.
areas 1000,
Yes,
1320, ma'am.
correct. Tanishka, is it?
Yes, ma'am. And
Very good.
diagonal
Yeah.
is 48 centimeter, ma'am.
Oh, that looks right. 48. Yeah, you're right. Yeah, Danya, I think you wanted to say something. Danya?
Yes, ma'am. I have been working on the last.
Okay, getting this?
Yes, ma'am.
Very good, very good. Yes, children. Please work. Done this one, children? Who can explain this? 36.5 square minus 27.5 square. How does that become this?
Ma'am, by the formula a square minus b square.
Yeah, you can do it like this. Correct. A square minus b square is a plus b into a minus b. Otherwise, you can normally, you can find the square of this one, find the square of this one and subtract and then take the square root. Done, children?
Yes.
Yeah? Done this one, children?
Yes, ma'am.
All of you?
Yes, ma'am.
Very
Yes,
good.
ma'am.
All right. So here the perimeter of the rhombus is given. So you know all the sides are equal. So each side is 36.5. You can see it marked in the figure. Now we need to find the length of the other diagonal and also the area of the rhombus. All right. Okay. So take up any one right triangle. All the four are right triangles. All the four are right triangles. Take up any one right triangle. And it's also given that the diagonal, the one of the diagonals is 55. So this diagonal, say this diagonal, one of the diagonals is 55. So say this diagonal is 55, this one. Find the length of the other diagonal and the area of the rhombus. So take up one right triangle. In the right triangle, you will have, just a second. Just a second, children. Yeah. Yeah. So perimeter is given 146. 4 into side is 146. So side is equal to 36.5. So all the sides 36.5. One diagonal is given 55. So AC is 55 is given. We need to find BD. We need to find BD. So we use Pythagoras theorem. Any triangle, any right triangle, I've taken AOB and I've applied Pythagoras theorem there. And then you can see I've treated it as A square minus B square, which is A plus B into A minus B. Yeah, on simplifying, we get AO is equal to 24 centimeters. AO is 24. Then what is AC? AO is only half of the diagonal. AO is equal to half of the diagonal AC. So AC will be 2 into 8, which is 24. And the other diagonal is AC, which is 2 into 24, 48. So we use Pythagoras theorem in one right triangle. In one right triangle, so I have taken AOB. In this right triangle, by Pythagoras theorem, this is the hypotenuse. And this is 55.5. So you know this is 27.5, half of that. So using this side and this side of this triangle, are you all following, children? One diagonal is given. This diagonal is 55. So that means it's half. 27.5 here and 27.5 here. Sides given, meaning perimeter is given. So we found the sides 36.5. Now using Pythagoras theorem, using this right triangle and Pythagoras theorem, you can find this one. Once you find OB, double it to get OD. And that way you can find the other diagonal BD. So here I think I've AO and AO is oh, I've substituted for OB, is it by mistake? Oh, okay. I've marked 55 here on AC, but I've substituted for OB. OB is what? Okay, children. You understand? Meaning, while substituting, I've gone wrong. Can you make out? No. Instead of for AO, I should write 27.5. But I've written for OB 27.5. The answer procedure is not wrong. While substituting, OA is 27.5. OB is not known. We should find OB and BD. Okay, let me correct it. So it will be like this. AO square is 27.5 square plus OB square is equal to this one. Then OB square is equal to minus 27. OB square is equal to this OB. So OB is equal to square root of 8 into 3, 24. So now that you got OB, BD, you must say BD is equal to 2 into OB. BD is equal to 2 into OB, so 48. Then the area of the rhombus is half product of diagonals. All right, children?
Yes, ma'am.
All right. Yeah, this is also simple. Please work this. Done this one, children? Done this one, children?
One minute.
Just a minute, ma'am.
Okay, yeah.
Completed, ma'am.
All right, all of you?
Yes, ma'am.
All right. So we first find the semi-perimeter. It's easy, you can assume x plus n, that's easy for you. Base is not any of the equal sides, remember that. In an isosceles triangle, equal sides are equal sides. Base is not the equal side. Let each equal side be x, so the third side, which is the base, is x plus 10. Then find the perimeter. The perimeter is given 100. So, you have to add the three sides. So x plus x plus x plus 10 is 100. So that way you can find x. And once you get x, you can find the three sides of the triangle. So the three sides are x, and x plus 10. So x is 30, another x is 30, and x plus 10 is 40. Then semi-perimeter substitute and find the area. All right. Yeah, do this one. Done, children? It's easy to understand, children, so I'm not explaining. Any questions, children? Finish this one.
No doubts, ma'am.
Okay,
It's clear, ma'am.
very good. All of you, please ask me, children, if you don't understand. So it's given that area of the trapezium is 5/6 the area of the rectangle. So 5/6 this one. On simplifying, you get 2125 by 2. This is the area of the trapezium, PBCQ. But that's given by the formula half sum of the parallel sides, QC plus PC. sorry, PD into distance between them, CD, is equal to 2125. Then substitute the values and find the value of X, and hence find whatever is asked, QC and PD. QC and PD. Next one, children. Done, children? Any questions?
Yes, ma'am.
Okay. Yeah. I'll just come back, children. Please work this one.
Completed, ma'am.
I don't know if anyone called out children. I was not here. Yeah, finish this one.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
All right. So for the assumption part, I would just like to tell you. Now see here, what is given? One side of the triangle is 4 centimeter longer than the smaller side. And the third side is 6 centimeters less than twice the smaller side. But we can see that, the other sides are dependent on the smaller side. So I've called the smaller side as X. One side is 4 centimeters longer than the smaller side. And the third side is 6 centimeters less than twice the smaller side. The remaining two sides are dependent on the smaller side. So I've called the smaller side as X. Let the smaller side be X centimeters. Now see here. So we have the second and the third side now. So this is the second side. The smaller side is the smallest. In fact, the smallest I should. Okay, we are not sure if this is the smallest side because we'll have to find the values. Fine. According to the word used here, the smaller side. So I've called it X. Now see here, children. One side. So I've just called it the second side. One side, that is the second side, is 4 centimeters longer than the smaller side. Okay, see here, the second side. The second side is means equal to 4 centimeters longer than the smaller side. Whatever is in English, just convert that to a mathematical equation. See here, one side, I've mentioned that as a second side. Okay, second side. One side meaning the second side. Is means equal to. Okay, 4 centimeters longer than. So than something, right? So 4 centimeters longer than meaning plus 4 here. Than what? Than the smaller side. So smaller side plus 4. See, whenever it is 4 centimeters longer than or shorter than, you should put the plus 4 or minus 4 behind here. So smaller side is X, so X plus 4 centimeter. So the second side is X plus 4 centimeter. And the third side is meaning equal to 6 centimeters less minus 6. Twice the smaller side, 2 into smaller side. So what's the smaller side? X. So 2x minus 6. I'll do it here again for you. See your children. I've taken the smaller side. Let the smaller side be X. Now then one side. So smaller side is one side, okay? Second side, third side. So we are finding the remaining two sides now. So the second side, okay, is. The second side is meaning equal to 4 centimeters longer. So I'll put a plus 4 here. Than what? Than the smaller side, X. Than the smaller side meaning X. So X plus 4. The second side is X plus 4. Then the third side. The third side is meaning equal to 6 centimeters less. 6 centimeters less than twice the smaller side. Twice the smaller side, 2x. So these are the sides. These are the expressions for the sides of the triangle. One side is x, another side x plus 4, another side 2x minus 6. Am I clear, children?
Yes, ma'am.
Yes, ma'am.
Yeah. You see here, second side is 4 centimeters longer than the smaller side. Third side is 6 centimeters less than twice the smaller side. So these are the sides, or these are the expressions for the sides of the triangle. These are the expressions for the sides of the triangle. Now the perimeter is given to be 50. So the sum of the three sides is 50. Working that, you can find x. Once you find x, you can find the three sides. You can find the three sides of the triangle. So find the three sides. 13, 14, 17 and 20. My calculation is right, children, everywhere. Did you check that? Okay. Then find the semi-perimeter. What's the question? The question is to find the area of the triangle. So now we have the sides. Find the semi-perimeter. Use Heron's formula to find the area of the triangle. All right, children?
Yes, ma'am.
Yes,
Okay.
ma'am.
Very good. Yeah, do this. The standard of this question is actually 8th standard. The standard is 8th standard. Let's see how many of you can remember and recall. Yeah, children. What's happening, children? Please let me know.
I'm working on.
Okay.
Ma'am, is the answer x is equal to 23, ma'am, and x plus 4 is equal to 27.
Very good. Very good, Danya. You're right. Yeah, those who were not able to do it like this. Done, children?
Yes, ma'am.
All of you?
Yes, ma'am.
Yeah. A point O is taken inside an equilateral triangle ABC. Okay, a point O is taken inside an equilateral triangle ABC. So equilateral triangle, a point O is taken. Say the point is here. Okay, triangle ABC. OL is perpendicular to BC. OL is perpendicular to BC, correct? Triangle ABC and O is a point inside the triangle ABC. All right, children?
Yes, ma'am.
Anywhere inside the triangle. You can take it anywhere. I have taken it here. Reading ahead, OL is perpendicular to BC. OM is perpendicular to AC. OM is perpendicular to AC. And ON is perpendicular to AB. ON is perpendicular to AB. Is this correct, children?
Yes, ma'am.
All right. Such that OL is 14. OL is 14. OM is 10. And ON is 6. Okay. With this information, we need to find the area of the triangle ABC. Given this information, we have to find the area of the triangle ABC. For this, what you have to do is you will have to divide. See, remember the idea. Working with numbers, addition, subtraction, multiplication, division, all of us know that. But what is that funda? What's that idea? How do we proceed? What is that with which we construct the equation? That is what is very important. So the equation is, see, we always need to construct an equation so that we can solve that and find the, missing value or the unknown values and hence answer the question. So what is that idea here? What you have to do is join OA, OB, and OC. Is that fine, children? That is join the that point O to the vertices of the triangle. Is it fine?
Yes,
Join
ma'am.
OA, OB, and OC. Now, can you see the triangle AOB? Can you see? Okay, see, I'll show the figure again like this. So we have something like this. The figure, the point O here, when you join, there's one triangle like this. Now, when you join OA, OB, and OC, children, when you join OA, OB, and OC, you're dividing the whole triangle into three smaller triangles, AOB, AOC, BOC, correct? When you join, when you join OA, OB, and OC, you are dividing the whole triangle ABC into 3 smaller triangles. And you know the altitude of the 3 triangles. You know the altitude. See, that's given to you, ON. This is OL. This is OM. All this is given to you. So what you should do is, the equation is the sum of the areas of the 3 small triangles is equal to the area of the whole triangle. That's all. You just have to write this. The sum of the areas of the 3 triangles, that is, here, area of triangle AOB plus area of triangle BOC plus area of triangle AOC is equal to the area of the whole triangle ABC. I showed you triangle, the point O is here, O. When you join O to the vertices, you're dividing the whole triangle into 3 smaller triangles. What are the 3 smaller triangles? AOB, BOC, and AOC. What is area of AOB plus area of BOC plus area of AOC? Area of the whole triangle ABC. Is this understood, children?
Yes,
Yes, ma'am.
Okay. Now, how do you find the area of triangle AOB? Half base into height. Half into base AB into height ON. Yes or no? Area of triangle AOB. What's the area of triangle AOB? Half into base into height. Okay, half into what's the base, children? AB is the base, right? For AOB, AB is the base, correct?
yes, ma'am.
Okay, and what is the side? What is AB for the equilateral triangle? Side, which is A units. In general, we say side of the equilateral triangle is A. That's what I've written. Into what is the height ON? 6. Now tell me for the others. What's the area of triangle BOC? Half into base into height. What's the base? BC, right? Half into base BC, correct?
Yes,
Into
ma'am.
height OL. How much is BC? A units, because the equilateral, all sides are equal. Into height OL, which is 14. Plus AOC is half into base
A,
A
ma'am.
into
10, ma'am.
10, ma'am.
10 is equal to root 3 by, because is equal to area of the whole triangle ABC, which is root 3 by 4 into A square. Is this correct?
Yes, ma'am.
That's all.
Ma'am.
Once you write this, you know how to proceed. That is the idea. That's the idea. So join OA, OB, OC. Let AB, BC, AC be equal to A units. This is the idea. Area of the 3 small triangles AOB, BOC, AOC is equal to the area of the whole triangle ABC. Then half base into height. Half into AB into ON, BC into OL, and AC into OM is equal to root 3 by 4 A square. Then we know AB, BC, AC all equal to A units because equilateral, all sides are equal. So you get whatever, 15A is equal to root 3 by 4 A square. So A and this A square will cancel out and you have A here. This is A and A square here on the other side. This is A and this A square. So they'll cancel and you'll have 1A here. So 15 is equal to root 3 by 4A. So A is equal to 15 into root 3 into, take the reciprocal. See here, 15 is equal to root 3 by 4A. So when root 3 by 4 is transposed, it will become 15 into 4 by root 3 is equal to A. 15 into 4 by root 3 is reciprocal on the other side is equal to A. So on working and rationalizing, you get A is 20 root 3. We need to find the area of the triangle ABC. We found the side is 20 root 3. So the area will be root 3 by 4 into A square. What is it? 300 root 3 centimeters square. Understood, children? Please take
Yes.
a screenshot and please take a picture of this one.
Taken, ma'am.
Yeah, take another one now. All of you.
Taken, ma'am.
Taken, ma'am.
Taken, ma'am.
Yes, children, please complete this in your book. Yeah, the rest we have discussed. All this we have done earlier. That's why I came from behind. Okay, children. All right. Yeah, all this I've completed earlier. All right. Yeah. Yeah, take this as homework. Please do this. Take a picture. Done, children?
Yes, ma'am.
Yes, ma'am.
All right. Yeah, this one also take a picture. Please work this, complete this in your notebook. And this one, that's all.
Taken, ma'am.
All right. Please complete these three answers and the today's that last sum, this one. Please don't forget. Important this is. This one. This one. And one more I just saw. Yeah. This also, children. All these are, objective questions. Yeah, take important this is. Take a picture of this one. What do you mean by A plus B plus C? In Heron's formula, what is A plus B plus C? Perimeter, right?
Yes,
Perimeter,
ma'am.
correct. That's nothing but twice the semi-perimeter, correct?
Yes, ma'am.
See, you know that S is equal to A plus B plus C by 2. When you cross multiply, what you get? A plus B plus C is equal to 2S. That is twice the semi-perimeter is the perimeter, correct? So that's what it is here. A plus B plus C is replaced with 2S because A plus B plus C is equal to 2S. Perimeter, what is A plus B plus C? Perimeter, that means twice the semi-perimeter. Okay, children, please take a picture of this one. Done, children?
Yes, ma'am.
Yes,
All
ma'am.
right, children. All right, yeah. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Thank you, children. Thank you.
Thank you, ma'am.